Hello guys, welcome back to Lead Logics. Today we'll be going to solve the question majority element 2. This question is also known as find the elements that appears more than n by 3 times in an array. So the problem states that we are given an array of n size and we have to find all the integers that appear more than floor of n by 3 times. Here n is the length of the array. So there is a prerequisite for solving this question, that is majority element. So I will give you the link to my majority element solution. You need to check it out, for it is needed in the optimal solution. So you can see for this in example we have 3 2 3. So the floor of uh, n by 3 will be 1. So it appears one time, it appears two times, which is more than 1. So the answer is 3. Now let us come to the brute force approach. First of all, we need to think how many can be a possible solution. How many integers can actually occur more than floor of n by 3 times in given array. So let's take an example in this one: 1 1 1 3 3 and 2 2 2. So here n is equal to 8. If we closely observe in the given array, there can be maximum of two integers that can occur more than floor of n by 3 times, because for n equal to 8 the floor value of n by 3 is 2, and for an element to appear more than floor of n by 3 times it need to be appear 3 times. So if we take 3 3 3, it will be more than the length of the array. So actually it can only occur 2 times in an array. So the maximum number of elements in the solution can be 2. Now coming to the brute force approach. In this brute force approach, we'll run a loop that will select the elements from the array one by one. And now for each element, we run another loop that will run for the entire array and count the number of occurrences of the particular element in the array. And if the count of the current element is more than n by 3 floor, then it will add in the result. And we'll also check if we have two answers in the result, we'll simply break, because if you have reached two answers, that means there can be no more integers in your solution, and that is the final answer. So let me show you the code for this. So you can see we have a list of integers as a result. This will be used to return the answer, and then we are running a for loop for each element, and we are checking if result dot size equal to 0, or if what the element is present at the in the list that is not equal to the current element, then only we are going to check for the current element. So we are simply count, we have kept a count, we are iterating to the entire loop of entire array, and we are simply, if it is same, we are simply incrementing the count, and we are checking if count is greater than n by 3, we simply add it in the result, and if the result dot size is equal to 2, we are breaking, because there can be no more than two integers in the answer. Now coming to the time complexity of this solution. The time complexity of this solution is O of n square, and the reason is that because we are using two loops. You can see the one is running n times, the other is also running n times. So the maximum or the worst case time complexity can be O of n square. Coming to the space complexity, that is O of 1, that is constant, because we are using a list that stores a maximum of 2 elements, so that is constant, and no other space is basically used other than the variable, so it is constant space complexity. Now this we need to optimize this n square thing, so we can use something like a hash map. So like if we use hash map, so let me give you an intuition. So what we can do, we can use a hash map and store the elements as key value pair, where the key will be the actual element and the value will be the frequency of that element in the array, and we'll traverse the whole array update the occurrence of each element. If the occurrence is greater than or it is equal to the required minimum count, we'll add it in the result, and if result size is greater is equal to 2, then it's the predator. So let me show you the code. So we have defined a hash map. We are taking a minimum count as the floor of n by 3 plus 1, and we are traversing the entire array. We are updating the frequency of each element, and if the frequency equal to minimum count, we add in the result. If frequency dot size equal to 2, we break. So how will the elements be added? Like for this example, in the hash map, uh, suppose the first element occurs, 1 is added one time, then again 1 occurs, so 1 comma 2, then again 1 occurs, then 1 comma 3, then comes 3, so 3 comma 1 will be added because it occurs one time, then again 3 comes, so 3 comma 2, and then 2 occurs, 2 comma 1, then again 2 occurs, that will be 2 comma 2, and then again 2 occurs, that will be 2 comma 3. So, and whenever the frequency will be equal to 3, it will be added in our result. So this was a dry run for this approach. So let me give you the complexity of this. So the time complexity of this will be n log n, where n is the size of the array, and for insertion in the map, it usually take log n time. So uh, it will be like for this example, we are using a hash map, so it will be O of 1 because insertion and hash map takes O of 1. But if you are using C++ and you are using an ordered map, it will use log n time, so it will be n log n. And the space complexity is O of n because we are using a hash map that will store at maximum n key value pairs. Now let's come to the brute force approach. Let's come to the optimal approach, because the brute force and the this better solution is still taking, the better solution is taking a n of space, and the brute force is taking n square of time. So we need to optimize these both, and we need to do it in linear time, that is O of n time and O of 1 space. So for this, we are going to use something known as extended Boyer-Morse voting algorithm. So what Boyer-Morse voting algorithm is? We need to keep 4 elements, that is count of 1, count of 2, element 1 and element 2. We'll traverse through the entire given array. If count equal to 1 and the current element is not element 2, then we then store the current element as element 1 along with the increasing count by value 1. And if count is 0 and the current element is not element 1, then we store the current element as element 2 along with the increasing count value by 1. And if current element and element 1 are same, we increase the count by 1. And if current element and element 2 are same, we increase the count 2 by 1. Otherwise, we simply decrease the count 1 and the count 2. So uh, let's take another example. So suppose for this, what will be the count 1 and count 2 will be 0 for this case. So count 1 equal to 0, count 2 will be 0, and element 1, element 2, these are like min for now. Now when we run the loop, so 1 occurs. So is count 1 0? Yes. So element 2 not equal to element ARR of 1. So element 2 is 0. Is it equal to 1? No. Then what we do? We put it element 1 as 1 and count as 1. and then all are if else, then it will go to another iteration. uh, then I becomes 2. So here I becomes 1 actually. So when I becomes 1, the we check the element. If count of 1 is 0, no, it is not 0. And element 2 is 0. Element 2 is 1. So element 2 is 1. No, but this is already false, so we'll not go into this. We check this. If count equal to 0, yes, count 2 equal to 0, and element 1 not equal to 1. So this will be false also. So we'll go in this. If 1 equal to element 1, yes, 1 equal to element 1, we simply count of 1 plus plus, it becomes 2. Then again 1 come. So then again it will go to this. If count 1 equal to 0, false. If count 2 equal to 0, yes it is, but element 1 equal to 1, not equal to 1, this will be false. Go to else if 1 equal to element 1, that is true, increment the count 1 by 1. So the next element what we have is 3. When 3 comes, if count 1 equal to 0, false. If count 2 equal to 0, true. If element 1 equal to 3, uh, no, 1 is not equal to 3, we'll do count 2 equal to 1 and element 2 equal to 3. And then the next step, again we have 3. So this will be false, this will be false, and this is 3 equal to 1. No. Is 3 equal to 3? Yes. Count 2 plus plus. This will be actually 2 now. So, and then we have 2. So when 2 occurs actually, this will be 0, this will not be 0, this will also not be 0. So both of these will false. This will be also false, and this will be also false because none of the element is equal to 2. So we'll go to this one and it decrease the count by 1. So count 1 equal to 2, count 2 equal to 1. Then again for the two same same thing occurs. So the count 1 and the count 2 will be again be decreased. Count 2 becomes 0, count 1 becomes 1. And now when the last 2 occurs, it will go to this count 1 equal to 0, no, false. Count 2 equal to 0, yes, true. Element 1 not equal to uh, element 1 not equal to 2, correct. What will we do? Count equal to 1 and element 2 will be 2. And now we have to go and iterate through the entire loop and count the occurrences of element 1 and element 2. And if the count becomes more than the minimum count, we simply add it in the result. So this was the extended Bohr's voting algorithm. So time complexity for this will be O of n and O of n, because one time we are here using O of n complexity, and the next time we are using to calculate the count. So the time complexity is O of n plus O of n, and the space complexity is O of 1 because we are only using a list of size 2 and no other actually space. So this was our most optimal approach. So you can see this gives a good runtime as well. 98.52% beats 98.52%. So this was our solution for the majority element 2. I hope you liked it. Please do like, share and subscribe my YouTube channel. Thank you for watching the video.